Good geometry students, in this video we're going to take a look at doing proofs with segments. First thing I'd like you to do is add this segment addition postulate to your reasons list. So grab that tan sheet of paper and go ahead and add that in there. So just this part, you don't need the first part where it says postulate. Now we've actually seen this before, so I want to remind you of what this means. If you've got a segment, and they've got this example here from A to C, and B is somewhere along the way, they're just saying that the distance from A to B plus the distance from B to C is the distance from A to C, the whole thing. Okay, so number one says B is between A and C somewhere, and then they gives you some expressions for the different parts of your segment. So I would suggest that you draw yourself a number line here. And we'll go ahead and we'll put A on there, C on there, and then B is just somewhere in there. Doesn't have to necessarily be the middle. We don't know that it's the middle. And then from A to B, this is supposed to be 3x. From B to C should be 2x plus 10. And then from A to C, this should be 6x minus 40. Okay, so remember when you start a proof, your very first statement should be the given. So you're literally going to copy down the given information up above. So B is between A and C. We know AB is 3x, BC is 2x plus 10, AC is 6x minus 40. And again, this is all given to you. Okay, step number 2 is we're going to want to do some algebra here, but first we have to state the geometry that's going on. So we need to talk about how from A to B, if you add that B to C, then you get the whole thing A to C. So we'll say AB plus BC equals AC. And this is called segment addition postulate. All right. Third step, we'll go ahead and we'll insert the algebra. So from A to B, we know that's 3x. B to C is 2x plus 10, and AC is 6x minus 40. And we are literally exchanging stuff here that's supposed to be equivalent. So this is going to be the substitution property. Now we're going to do some algebra. So on the left-hand side, the 3x and the 2x, so you can just say, well, I actually have 5x's over here. And when you put those things together, it's combining like terms. We'll use the word simplify for that. Alright, then I'm thinking I'm going to subtract the 5x on both sides. So that's going to leave me 10. 6x minus 5x is x. And then minus 40. And I'm thinking what I did there was subtraction property. Okay, next I'm going to add 40 over to the other side. So I'll get 50 equals x. Addition property. So my goal here was to get xt equal 50. And we're there. Some people might have a technicality with this and say, well, technically you're supposed to have the x on the left and 50 on the right. And we actually have a reason why you can flip those things around and they still mean the same thing. This is called the symmetric property. And hey, we made it to the end of our proof. Okay, so the symmetric property is amongst these other properties here. Reflexive property, there's the symmetric, there's transitive. So these are things you've already written down, but let me review with you what these things mean. So when you're talking about reflexive property, it's just when something is congruent or equal to itself. So they got some angles here that, A is the same as angle A. Segment B, AB is the same as segment AB. Symmetric property, we just did that up above. That's where you switch the side of the equals or congruent sign that you're on. Means the same thing. And the last one, transitive property, this reminds me of the law of syllogism where you can cut out the middleman. So like if you look at, let's look at the second one here. Notice you got A being the same as B and B is the same as C. So if you cut out the B's, then you could say, oh, well, A is the same thing as C. And that's just demonstrated a couple more times there. So we're going to try out a couple problems. We're just trying to figure out like which is the property that they are talking about that would justify going from the first statement to the second statement. So if you look at A, they talk about O being the same as W, W being the same as L. Well, you could take out the W's and say, well, that's the same thing as O being congruent to L. That's like the last one I was talking about. So this one is going to be transitive property. This one just says angle A is congruent to angle A. It makes sense. Something's congruent to itself. This is reflexive property. Part C, they switch the order. They say E is the same as T, T is the same as E. That's going to be symmetric property, like what we did in the last proof. And then part D, we got segment EF congruent to segment CD. Segment CD is congruent to segment WT. So those are the same, they can go away, and then you can say, oh, segment EF is the same as segment WT. So this is called transitive property. All right, let's see what's on the next page here. We're going to check out a proof here that doesn't involve algebra necessarily. So remember when you start a proof, you always start with the given. So we'll copy that down. QT is congruent to RV. And the reason here is given. All right. So in step number 2, I'm going to talk about Q to T. And check it out. From Q to T, you could actually break this up into QR plus RT. So that's what I'm going to write down. QT is QR plus RT. And what you're doing is segment addition postulate. And I'm picking on QT because it was part of our given. So the next one I'm going to pick on is RV. And I'm going to do the exact same thing. So RV, check it out on your picture. So RV could be broken into RT and TV. It's going to be the same reason. Segment addition postulate. Alright. Now, up at the top in number 1, we said QT and RV are the same. So you could argue that instead of writing QT there, you could write QR plus RT. Let's do that. QR plus RT. And then likewise, RV, you could replace that with RT plus TV. And so what we're doing there is some substitution property. I got some funky spelling there. That's okay. Maybe I'll fix it. Okay. Now, if you look closely at step number 4, you will notice that there's an RT on both sides. So essentially we're going to subtract those. And so that leaves us with a QR and a TV. Those things are equal, or in this case, technically when you talk about segments, you should say they're congruent to each other. And that's what we wanted to prove up above. And again, what I did was I subtracted the RT from both sides. So this is subtraction property. And we made it to the end. All right. In example number 4, they say E is the midpoint of DF. And you can even see those little tally marks in there. Let's go ahead and copy down that given. Okay, I need a geometry step here. So what I'm going to say is if you have the midpoint, that means that each side is congruent. So we're going to say DE is equal to EF. And the reason here is going to be definition of midpoint. All right, step number 3. Instead of DE, let's go ahead and put in that whole algebra thing there. And instead of EF, let's do the 36 plus 2x. And what we did is we substituted that in, so substitution property. And then from here, we're going to do some algebra. I'm thinking let's distribute the 3 through. So this would be a 9 plus 24x plus 5. That was the distributive property. Then let's put together the 5 and the 9, so that's 14. And they're just on the same side. So I know we added them together, but we didn't add anything to the other side of the equation. So this is simplify. Okay, then I think what I'm going to do is I'm going to subtract the 2x over. So instead of 14, this would be 22x equals 36. That was subtraction property. Oh, I'm starting to run out of room. And then I'm going to subtract the 14 over. Oops. Again, subtraction property. And then my last step is I'm going to divide by 22 on both sides. So x equals 1. Hopefully that's what I wanted to do. Yep, prove x equals 1. And that to get to that last step, what we had to do is we had to divide. So this is going to be division property. Woohoo, made it to the end. Okay, not the end of the notes though. We got one more problem. Last one. So they say R is the midpoint of QS. QS is over here, so R is the middle of that. T is the midpoint of VS. And then they say QR is congruent to VT. QR is congruent to VT. Okay. So that's a lot of given, but yes, we do need to write this stuff down. So I'm going to go ahead and do that. Whew. Okay. So let's go ahead and expand on some of this. Like they say R is the midpoint of QS. So if R is the middle of this, we could say QR and QS are going to be the same. QR and RS, sorry. And this is what it means to be a midpoint. So definition of midpoint. And actually, you could say the same thing. I'm just going to sneak this on the same step. You can do this because of the same reason. And I'm going to say VT is congruent to TS. Because it's also going to be a midpoint there. All right, number 3. Where are we trying to get to? Okay. So I'm looking at like these two right here. And if I was to put those two together, notice they're both congruent to QR. So someone could argue that RS is congruent to VT by cutting out the middleman and saying that's transitive property. And now if I go to step number 4, if I was to take, let's see, these two, notice that they both have VT in them. So you could take those out and say that RS is congruent to TS. And that's what we wanted to do, right? That's what we're trying to prove up there. So again, I cut out the middleman. That's going to be a transitive property. Hey, I got where I wanted to go. All right. Hopefully you got something out of that video. Thanks for watching, you guys. And I hope you have a great rest of your day.